Today I'll talk about using symbolic execution to analyze the Linux KBuild Makefiles. So we all know that the Linux kernel is very popular, very active, and it has been used in a wide range of systems, from tiny sensor to mobile devices to desktop and supercomputers. The kernel is highly configurable. The latest version 5.x has more than 13,000 configuration options, which is about 2 to the 13,000 possible configurations. So the kernel is built using the traditional Makefile system, which control how configuration options would affect the compilation and linking of individual C files into the kernel. So Makefiles are written in the Make language, and they consist of rules to build these files. And the kernel Makefiles, called the KBuild Makefiles, are basically Makefiles, but with specific structures and conventions used by Linux developers. There are about 500 of these KBuild Makefiles in Linux, and KBuild Makefiles are used not only in Linux, but in many other open source system level software. So in 2018, there's the Linux Foundation, through a Google Summer of Code project, proposed to analyze these KBuild Makefiles to discover build conditions over configuration options. So they say that there are many beneficials for finding these build conditions. So for example, we can find orphan files. We can test important configurations and see how they affect important files. We can determine how making changes to a file will affect some configuration. Okay? We can use that to estimate the kernel build time and size. And it can also reveal important and interesting information on how Linux built its kernel, like what kind of build conditions there are, what options are important or influential. But they also mentioned that this is a very difficult task to collect these build conditions because the Linux has such a large configuration space. So we propose to use symbolic execution, which is a very popular testing technique, to analyze the KBuild Makefiles. We'll treat configuration options as symbolic inputs, and we'll simulate the execution of the make program over these inputs. And when there are conditions over these config options, we'll fork them into multiple branches. And while we do that, we'll collect these path or build conditions over these configuration options mapping to source files. All right. So here's a small example. Here from line 2 to 5 to 6, you see a conditional statement that check to see if the option A has a value Y, yes, and change the value of bits accordingly. Line 7 looks a bit strange, but that's just a typical Makefile syntax, which says that expand the values of options B and bits into all possible values that it could have. All right. So this is the build conditions for this small KBuild files. You can see that it captures how these files are included in the kernel. For example, for any configuration, fork all would be included. And when the condition is A and B are true, then we'll have fork all as well as probe 32. Okay, and this is a traditional symbolic execution tree generated from symbolic execution to capture, to collect these build conditions. But if we just use standard symbolic execution, then it will not be feasible because Linux has just too many options to consider. So we could use several unique properties in KBuild Makefiles to make symbolic execution efficient. So the first thing is that even though Linux has very large configuration space, but it has only 13,000 source files, much smaller than the number of config space. So we could merge path conditions leading to similar files. So that saves a lot of paths. Okay. We could also use traditional static analysis techniques such as live value analysis to detect when variables are no longer being used. And if that's the case, then we can discard or we can merge paths involving these variables together. So we have a prototype, and we have evaluated that for BusyBox and Linux. BusyBox is a well-known suite of common command lines programs, and it has about 500 configuration options. Okay, and within 30 minutes, our prototype were able to analyze all of these files and obtain build conditions. We tested our prototype on Linux, and it also works well for most files, including large ones, 100 options each. But it failed on some of the largest one, and we are currently implementing additional optimization, for example, the live value analysis that we mentioned, to make the prototype more efficient. Okay, so that's all. Thank you.